Hi. Today, I think it's day 3. We're studying parallel, perpendicular, and coinciding lines. The essential question or the learning target is to be able to identify if two lines are parallel, if they're perpendicular, or if they're the same line. Before we start any of our examples, first we have to classify the different kinds of systems. Now, a system is when you have two equations next to each other and you're comparing them. So these are the 3 different possibilities. So you have one pair where they just intersect. And when two lines intersect, there's one solution, there's one point there. And so that's known as one solution, and it's consistent because there's one solution. We have coinciding lines, and I tried to color code them so you could see that they're overlapping. But coinciding lines have infinite many solutions, and that means how many points do they intersect? Well, every single point is going to be the same, and so that's why it's infinite, and it's consistent because it has at least one solution. The last pair are parallel lines, and you can see parallel lines will never intersect, and parallel lines, that scenario will have no solution, and it's known as inconsistent because they never intersect. So one thing we have to think about is something way back, I think it's geometry, we do a lot of this, proofs is parallel lines. You have to remember, and sometimes we use this symbol with the 2 bars like that, have equal slopes that are equal. So you're going to look at your 2 equations and see if the slopes are equal, then you know that they are parallel. That will be one scenario. Another scenario could be perpendicular lines. So perpendicular lines have slopes that are opposite reciprocals, and sometimes we use this upside down T for perpendicular. So you might not remember what an opposite reciprocal is. If you have the fraction 3/2, the reciprocal will be 2/3. What makes it opposite is the opposite sign. So that means one will have to be positive and the other is negative. Another example of that would be if you start with the integer of -5. So that means the slope of the other line has to be positive. And then you have to flip that because there's really this is over 1 here. So 1/5 would be the opposite reciprocal there. There is one other scenario that you're going to come across during your homework, and you could have the possibility of coinciding lines. And that's when they are the same line. There's lines that are overlapping, like if one line's here, it's right on top of it. And so those lines have a lot in common. They will have the same slope and the same y-intercept. And so you have to be careful there because sometimes kids just see equal slope. They say, boom, they're parallel and they're done. But they do have to, you do have to double check to make sure that your y-intercept is or is not the same. And if it is the same, then they're coinciding. So I made a little example for you so you could see how we write the problems from our end. If we had the equation x plus 2y equals 3, what I did to get a second equation that's the same as I just took the number 2 and I multiplied each by 2 to get that other number there. Now, you wouldn't do that. I would give you these, but that's kind of what you're looking for, is there's going to be some kind of multiplier in there, and then we change the form. So here are some examples of what you might see in your homework, okay? So, and if I go to, I'm trying to read this quickly so that you guys can pause when you need to. So you need to classify the system of equations, that's 2 equations, to see if they are parallel, perpendicular, and coinciding, or even none of these. So you always, I'm trying to teach you like a routine. So you always want to look at slope first. So this one is a little bit difficult to see, so I'm going to start with the easier one. So here I know that my slope is -2/3. So I want to know what the slope is of this other line. So what I've done is I rewrote that line, and then I subtracted 2x from both sides, and then I have that negative 21 that I brought down. To get y by itself, I divided everything by 3. And so then what you'll see here is if I divide this by 3 and divide this, I get m equals negative 2/3, which is the same here. So right now, I know that those two lines are parallel because they have the same slope. Now, the other thing that I need to pay attention to, because they're parallel, I need to double check that y-intercept. So the beginning one was a negative 7. So if I take negative 21 and divide it by 3, don't you get negative 7? So that's not m though. So negative 7, that's actually what b is, isn't it? So b equals negative 7 for both of those. So what that means is, because they have the same slope and the same y-intercept, those lines are coinciding. They're the same line. I do have another example down here. So example 2, I I drew these ahead of time. When you have x equals negative 3, what I want you to do is think, where is negative 3 on x? So this is the x-axis, and I moved left 1, 2, 3. So that's going to be that blue line. That blue line is that vertical line. That's going to have a slope. Your m, let's make it blue. Your m is undefined in this case. Whenever it goes up and down, when it's vertical, it's undefined. Now your y equals 5. I'm going to look on my y-axis now. And from 0, 0, 1, 2, 3, 4, 5, that's a horizontal line. And whenever it's horizontal, it has a slope of 0. There's no hills. You're not going up or down. So this one has m equals 0. Now, by looking at the picture, you can kind of see, hey, these two guys, they form a 90-degree angle. So then, therefore, these lines are perpendicular. Some people want to know a little bit more. So I'll show you this line. Since this is m is 0, isn't the fraction, if you do 0 over 1, isn't 0 over 1 still equal to 0? And so if you take that reciprocal of 0 over 1, that would be 1 over 0. And 1 over 0, you know, is undefined. So that's another way you could look at it. On the next slide, I have 2 more equations, your system. This one now is in your point slope, and then this one is in standard. But you always start with the slope first. So I can see what this one is right away, but I don't know what this one is on the second one. So I'm going to walk you through. I thought I had 2 bars here, maybe not. Hold on. So this is the second time I'm recording the video because it didn't record for the first time and I had moved my little boxes around. So because I know what the answer is, I'm going to do a little bit more work up front. So I'm going to simplify, do some algebra to move the point slope form into slope intercept form. So what I have to do is I have to distribute that 3/5. And to distribute the 3/5, I put the 10 over 1 so that I can multiply the 2 fractions together. 3 times 10 is 30, 5 times 1 is 5. And then I can simplify that. And I know nothing else changed. I just changed the 30 divided by 5 to -6 or -6 here. And then I'm going to add the 7 to the 2 sides, and a -6 and a +7 equals 1. So my equation for the first line is y equals 3/5 x plus 1. So I look at the standard form one. I'm going to move the 3x to the other side. So I have a -5 equals, a -3x minus 10. Divide both sides by -5. This will make y by itself. I have then a positive 3/5, and then I have a negative divided by a negative will be positive, and 10 over 5 will wind up being 2. So what we have here is we'll have a y equals 3/5 x plus 1 and 3/5 x plus 2. So what do we know? We just know that the lines are parallel. They have different y-intercepts. They're close, but they're not the same. So those lines will be parallel because they have equal slopes. The last and final example that I have for you is here. Now, when you have these wordy ones, it says give the point slope, slope intercept, and standard form of the equation of a line parallel to y equals 3/2 x plus 5 through this point. So I circled parallel because that's the word that you have to zero in on. It's not the form of the equation. You'll get to that part in the end, but you have to know where to start, and you have to find a line that's parallel to this line. So again, we're starting with slope. Always start with the slope, and you know that the slope of the line is 3/2, right there, your M. Now, this will change to perpendicular, and when it does, then you know that you're going to have to change this to the opposite reciprocal instead. And then here's your point. So once you find the slope, then you plug it into the point slope formula, which is y minus y1 equals m times x minus x1. I encourage you guys to write that down every time. It'll help you remember it. So now I got to plug stuff in that I know. So I know the point, and I wrote x, y here because sometimes kids mix the order up between the 6 and the 1. Remember, the 1 is the y, so that's why we're going to do y minus 1. And then the 6 goes in for x, this x here. And so it's a minus, and then that's 6, and then we plugged in our slope. And this right here answers actually one of the questions. You'll put that next to your PS on your worksheet for point slope. Now the second part, what we'll have to do to get the slope-intercept form is you do some algebra. So you'll see I put the 6/1 so that it's a fraction. So when you multiply 3/2 times that 6/1, it will be 18. And then 2 times 1 is 2. And then everything else had stayed the same. And now we can simplify that 18/2, changes to a 9. Everything else stayed the same. And then I'm going to add the 1 to the other side. And so then I wind up getting y equals 3/2 x minus 8. And that automatically changed it into the slope-intercept form. Here's the slope, here's the intercept. Now, up in the question, it says give the point slope, check, did it. Give the slope intercept, check, did it. Now we need to get it in standard form. And remember, standard looks like ax plus by equals c. The x and the y have to be on the same side. So to change this into standard form, what I did first, because I hate fractions, is I got rid of the fraction. So what I did is I doubled everything. So I multiplied everything by 2. So if I double the y, now I have 2y. If I double 3/2, I have 3x. And if I double this minus 8, I get minus 16. So these two are the same line. They're just different forms. And now, again, ax plus by equals c. So I got to move this 3x to the other side. So I'll subtract the 3x from the two sides. So I have a minus 3x plus 2y equals a negative 16. Now the rule for standard form is ax plus by equals c. And this has to be a positive integer, but right now it's negative. So I'm going to multiply the whole thing times a negative 1. So that just makes the signs change, the negative to a positive. So if I do it to 1, I have to do it to every term. So this changes to positive, negative, positive. And there is your standard form. Okay? Good luck.